So let's start with point number 6. Use indexed views for aggregated SQL queries. Let's try to understand that how point number 6 will help us to improve our SQL query performance. Now before we move ahead, let's try to understand what basically is a indexed view. Index view is nothing but it's a virtual table. A table which is persisted, whose result set is persisted on the hard disk. So what index view does is it represents the output of a select statement, which is the select statement will have normally a pre-calculated data like aggregation, summations, counts, etc. Now this data which you get from that SQL statement, the result set of that SQL statement is persisted on the hard disk. And because the data is persisted, the SQL engine doesn't have to go again and again and get the data from the base tables. So what it does is it takes this persisted data which is already existing in the indexed virtual table and it gives it to the end user. So because of this you save a lot of overheads. Now in general, when we create a view, the view does not store any data. So if you create a normal view, it doesn't store any data. So normally when you query a normal view, it will always go and query the base tables. So this persistence or this creation of virtual table is only with index views. Said and done, it is not that index view is the best thing which you will always suggest in all situations. Like for example, if your table is highly transactional, so in other words your base table is having a lot of insert, update, deletes, then index view is not the right thing, because the synchronization between base tables and index view is a time consuming task or is a resource intensive task. So what we'll first do is that we'll first try to understand that how index view helps us to increase performance, and then we will try to see what are the advantages and disadvantages of the same. So in order to prove our sentence, what we'll do is that we will do the following. We'll take up a simple table. We will do inserts and selects on that table without indexes, and we'll record the reading of the logical scans. Then we will create an index on the table and we will again record the select and insert logical scans. We will then create an index view and then we will record select and insert logical scans. And then we'll try to compare all these readings and conclude that in what situations index views are good and in what situations index views can hamper your performance. So let's start with the first step. Let's take up a simple table without indexes and let's record the select and insert statement logical reads on the table. Now here's a simple table. I have a customer table with 3 fields: customer code, customer name and register date, and currently I have ensured that there are no indexes on this table. Now what I'm doing is I'm firing a aggregated query here. So I'm firing a select query with a statistics on. Now this query basically what it does is it does a group by on the register date, and I'm having a simple count statement here. Okay, this counts basically on this date how many customers were registered. Okay, so it basically shows me a count. So what we'll do is that we'll run this query. This query is run without indexes on the table. So let's do a select. So over here I can see that on the select statement without indexes the logical read is 17. Now let's go and record this logical read in Excel file. So here's my simple Excel file I have. Just let me pull this up. So let me say without indexes the logical reads were 17. So let me just put here 17. Right. Now let's go and do an insert statement. So let's go and fire an insert statement. So let me just, so here's a simple insert statement, and again let's make the statistics on. So customer new, right, the logical reads is 1. So with no indexes the select statement took 17 logical reads and the insert statement took 1 logical read. So let me just record this. Now let's do the second step, or let's take the second reading with cluster indexes. So what we'll do is that we'll go and create a cluster index and we'll then again record the select and the insert logical reads. So let's do the second step. So let me go to my management studio. Let me go and quickly create an index. So I'm creating an index on customer code currently. Okay, because the group by is on the register date, let's create an index on the register date. I think that's more advantageous. Just save it. Now let's go and first get the select value. So here's my select statement. Now this is with indexes, so let me just fire this, and I'm seeing that the select statement with indexes, the logical read is 11. So let me again go to my Excel sheet and say okay, that is with cluster indexes. And let me also go and fire my insert query. The logical reads have increased here, so again let me go and record the same in my Excel sheet. Right, so basically I've recorded my cluster index read for select as well as for insert. Now let's do the third step, create an index view and again record the select and insert logical reads. So let me just go back, so let's do the third step, measure logical reads for select and insert with index views. So the first thing is we need to go and create an index view. Now let me just pull up. So here's a simple index view which we're going to create on the same select statement. Now in order to create an index view, what you need to do is that you need to first create a view. So the same SQL statement I have taken and I've created a simple index view first, a view by name index view, and then I've created a unique clustered index on this index view on the r_date column. Right. So this is the way you create an index view. You create a view and then you create a clustered index on the necessary fields. So at this moment I've created the cluster index using the r_date column. So let me just execute this. Okay, customer new. I'm pointing towards the wrong database. So here's my view has been created. In case if you want to see, you can see the view in the views section also. Now let's again go and start recording our readings. So let's go and record our readings. So let's do a select. So you can see that the select has two logical reads. So let's go and again record our statement there, saying okay, by index views the select statement has taken only two logical reads. Let's go to our insert. Let's again fire the execute. Now if you see here, there are multiple logical reads which have taken place, because if you remember that there is also an index view which needs to be updated. So it is 12 plus 3 15 and 15 plus 6 21 logical reads. So let's put here 21. So let's analyze the reading, and you can make out from the reading that when you created an index view, the select query performance increased in a very drastic manner. So you can see that when it was no indexes, the logical reads were 17, while with index views the logical reads are only 2. That's a marked performance improvement. But if you look at the other part, that is inserts, with no indexes, the inserts logical read or logical scan was 1, but the index view it has taken 21. So the insert part of the indexed of your index view is worst. So now let's again come back to the same question. So when should we use an index and when should we not use an index view? Now if your table is not highly transactional, that means you are expecting only select queries to be fired and less inserts, then you should go for index view. Now, and if you think that your table is highly transactional, so there's going to be a lot of insert, update, deletes, then putting an index view can worsen your performance. Just to go inside depth to understand that why insert queries were slower on index views, basically what happens, let's say that you have a base table, and if your base table is highly transactional, when I say highly transactional, in other words, there are a lot of insert, update, deletes query which are fired on the base table, then this synchronization between index views and base table is a bit resource intensive. So that's why the index queries are very slow when it comes to creating, when it comes to index views. So use index views where your table is not transactional and you have a lot of aggregation and summation information which you need to display. And do not use index views if your base table is highly transactional. Probably try to use other methods like creating indexes, cluster indexes, or trying for minimizing the size of the index, etc. But this point you can completely eliminate if your table is highly transactional. I hope that you have enjoyed this session, and in the coming up session we will discuss more about how you can suggest a plan to be utilized. So for example, let's say that you have a select statement and you have a stored procedure which is doing a simple select, and you want to basically say that, okay, use a table scan, use a seek scan. So that's what we'll be covering in the coming videos. So stay tuned in this video series. I am sure that this video series will be eye opener